The universe serves up spectacle after spectacle with so much ease and effortlessness that you cannot help but wonder how it has so many complexities hidden with its ulterior cloak of beauty. On the surface, the universe is magnificent and splendid. The immortal souls that are credited for creating it are not yet finished with it. Perhaps they get lost in its admiration and its beauty and lose track of the job at hand. The fact that the universe can be so alluring despite its intricacies is in itself worth cherishing. But like all things, the universe will come to an end. To predict an ending, you would have to understand the beginning. Like all spectacular things, the universe too had a spectacular origin, and that beginning was the Big Bang. The Big Bang theory explains the evolution that the universe had to undergo. This theory states that the universe was initially extremely hot and dense. As time passed, the universe began to cool and expand. According to the standard model, the four fundamental forces in the universe are gravity, strong and weak attractive forces, and electromagnetic radiation. Of the four, gravity is considered to be the weakest. There was a hypothesis that during the beginning of the universe, that gravity was as strong as the other fundamental forces. All the matter in the universe was condensed into such small spaces that the gravity had to be extremely high. The universe did not stay in its condensed state for too long and began to expand. For as long as we have known, the universe has been expanding. During this process of expansion, lots and lots of space was created. Galaxies began to move apart since the space between them increased. Within the galaxy, the space also expanded. However, the gravity acted as the glue that kept it all together. The gravity provides the force that keeps the galaxies together. It is strong enough to negate the expansion. In the Big Rip scenario, the rate of expansion increases so drastically that it reaches a point where gravity cannot counter or negate the effect of the expansion of space. The acceleration of space expansion would be tremendously high. This would result the universe to rip, and this phenomenon is called the Big Rip. This effect would start with the larger bodies and slowly propagate to the smaller bodies. It would first start with the galaxies. These galaxies would get ripped apart. Then black holes, stars, and planets would die. Since the gravity is not that strong enough, they would just dissolve into their constituents. Simply put, the difference between the Big Freeze and the Big Rip is that in the Big Freeze scenario, matter does not disintegrate. It gets converted into radiation in a process that could take, forever. To understand this, you will need to understand what entropy is. The second law of thermodynamics states that the entropy of an isolated system can never decrease. Therefore, every body moves to a state which increases its entropy. This means that every body cools down and it disintegrates until it reaches some form of equilibrium. Now, this is true for the universe as well. The matter in the universe slowly disintegrates and spreads out. Every single body, whether big or small, will have its matter disintegrate into radiation. The gas clouds required to generate stars would disintegrate. The universe will become an extremely dark place as a result. The suns would also disintegrate. Black holes would be the only entities left in the universe. Gravity, which is the weakest of all fundamental forces, could one day become the most powerful. Now, this is possible if the amount of dark energy reduces substantially over time. This would mean that the universe would simply stop expanding. And now this would mean that the rate of expansion would slow down at some point and keep slowing down until the process of expansion ceases. Then it slows down even more and more and more, and it reverses. Now the universe, instead of growing, would begin to contract and become smaller and smaller. Galaxies will merge and the universe will get significantly hotter. The temperatures would reach such high levels that bodies cannot bear such temperatures and it will disintegrate. Everything will get denser. Black holes that consume everything close to them would begin consuming bodies. As things get closer and closer, more objects would get closer to black holes. These black holes would consume everything, including other black holes. The amount of gravity will be immense. All black holes will eventually form a single supermassive black hole at the center of the universe. Our planet will cease to exist in about 1 billion years from now. The sun would burn 10% brighter, and the heat from the sun would dry up all the water on the earth. All life will be extinguished. In about 5 to 8 billion years, the sun would undergo such expansion to reach a size so big that it would devour most planets. In about 1 trillion years from now, all galaxies would merge into one. In 100 trillion years, we would enter the degenerate era. This era is marked by the death of all stars in the galaxies, which result in black holes. In 10 to 100 quintillion years, everything would be consumed by black holes. In a decillion years' time, we might have the black hole era where the universe is dominated by black holes. Eventually, these black holes will lose energy in the form of the Hawking radiation and die too. And in a googol year, the universe would cease to exist. The universe can die, but it has the potential to start all over again. The reality that we observe today may not be considered reality at all in the distant future. Whether the universe ends or not, one thing is certain. The universe should be cherished and celebrated while we all can still bask in its splendor. I thank you all for watching this video, and to watch more videos from AtomsTalk, please do hit that subscribe button in the bottom right hand corner and leave a like on this video without fail. And I will see you in our next video. Take care.